Alright, so we're going to take a look at 2.2 in this video for Algebra 2. This chapter is now getting into the equations of lines, and so part of that, equations of lines, is going to deal with the slope of a line. And so that's what this lesson is all about. So let me just point out a couple things up here in the vocab, because there's a really big formula that we're going to be using quite a bit in this whole chapter. So in dealing with the slope of the line, slope really just has to do with the direction of the line. Whether it's going up or down, or whether it's steep or horizontal, things like that. So if we were to take 2 points, so here's my first set of points, we're going to call those my first x and y. And if this is a different point on the graph, so we're going to call those our second x and y point. If we were to look at the slope of the line that passes through those 2 points, we always look at the rise over the run. And so you probably heard that phrase before. That's a big one in Algebra 1. The reason we say that is because it is the difference in our y values, which is how the line goes up and down, right? You think of your y values as going up and down. So the difference in our rise over the difference in the run is what the graph is doing from left to right. And so that's why we get the x's on bottom. So y minus y over x minus x. So that's a real big formula that we're going to be using. That's how we find the slope of the line. If we run into a case where two lines have the same slope, so if the slope of the first line is equal to the slope of the second line, then we have parallel lines, right? It means they're running the same direction if they have the same slope. If you had two lines that were perpendicular, those are the slopes that would be opposite reciprocal slopes. So they would have opposite signs. One would be positive, one would be negative. And one slope would be the reciprocal of the other slope. So if I were to take this slope and flip it upside down and change its sign, I would get a perpendicular slope. Alright, so let's get into a couple examples here. So you should be filling out your notes as we go through these. So first example we got to look at is just simply finding the slope of a line. If I have 2 points like this, I can use the formula that we saw up above. If I am looking at a graph itself, we can also simply count the rise over the run and get my slope that way. You'll notice on this one that this graph is rising. 1, 2, 3, 4. So it's rising 4. And it is running 1, 2. So it rises 4 and runs 2. So if we were to reduce that, we can see that the slope of that line is simply 2, or 2 over 1. It is good to get in the habit of leaving your slope as a fraction, because we always like to have a comparison of rise to run. So it is good to leave it in fraction form. You don't have to. You could write your answer as just 2 in a case like this, and that would be fine as well. But if we did not have the graph to look at, and I needed to use the slope formula, it would go something like this. So remember, the formula up above would be to take my second y minus my first y. So we're going to do my second y value minus the first y value. So y minus y over my second x, which is 1, minus my first x, which is negative 1. So I have x minus x. Right, and that would be the setup with the formula. Of course, 2 minus negative 2 is like saying 2 plus 2. And 1 minus negative 1 is like saying 1 plus 1. So you can see we're getting the same slope with the formula that we got by looking at the graph over here. Quick reminder, if you're ever looking at a graph to get your slope, we always work from left to right. So because I am going up and right, I'm going positive and to the right. So that's why my slope was positive. If I had a line that was running this direction, I would be going down and to the right, and so it would be a negative slope if it was ever running this direction. So just something to keep in mind. So here's one you can try for practice. This is one that you do not have a graph for, and so you would need to use the slope formula for something like this. Of course, when you guys are doing this in homework, I want to see the setup like this, so make sure that you're showing your work on how you're getting your slope. So for this one, again, using the formula, I encourage you to pause the video at this point and try this on your own before you watch me do it, just to make sure you're good with this. So if we do our y minus y, so I'm going to do my second y minus my first y. So 3 minus 0 over my second x minus my first x. So 1 minus 0. So if we clean that up a little bit, you can see that our slope is 3 over 1, or you could just say 3. One thing to keep in mind, we know the formula says to do y2 minus y1 over x2 minus x1, and that's all good. You can switch that around. If I wanted to do this y minus this y, that's fine, as long as I do this x minus this x. So as long as you're kind of keeping the same flow of information, you can do that in either order. So moving on to example 2. When we look at the slope of a line, this tells us what direction the line is going. So if I see that my slope is positive, like this one was, I know that my slope is going up and to the right. If I had a negative slope, then I know it is going down and to the right. If I had a 0 slope, right? So if anytime I get a 0 on top, right? 0 divided by anything is 0. So if I get a 0 slope, that means it has no slope, which means it's a horizontal line. Think of it as like a ski slope, right? If there was no slope to it, you would be standing on flat ground. You would be standing still. You're not moving forward or backwards. So a 0 slope is a horizontal line. If you ever get 0 on bottom of your fraction, remember you are not allowed to divide by 0. If you go into a calculator and type in 3 divided by 0, it's going to say error, right? Because you cannot divide by 0. So anytime you get a 0 on bottom of your fraction, that means it does not have a slope at all. It does not exist. And that's anytime you have a vertical line, right? It means you do not have a slope at all. It does not exist. So let's test a couple and see what kind of slopes these guys would have. So if I just did my y minus y over x minus x, you can see on this one right off the bat, I'm getting a 0 on top. So here's a graph that is a 0 slope because I got 0 on top. So anytime you have a 0 slope, we always know that comes with a horizontal line. So we could classify this one as horizontal. I'll go through these real quick just so you can see a few examples. So again, on this one, if I did my slope formula, so y minus y over x minus x, a little cleanup, and we can see that it is a positive slope. So anytime you have a positive slope, it's going up and to the right. So we would say that this slope is rising. Because it's positive, it's going up and to the right. On part C, again, if I did y minus y over x minus x, you can see on this one I'm going to get a 0 on bottom, right? Which, remember, you cannot divide by 0. So if I go into a calculator and hit -3 divided by 0, it's going to say error because you can't do that. So anytime you get a case where it's like a no solution case, right? I cannot have 0 on bottom. That always goes with a vertical line. A vertical line has no slope. So we could classify that one as vertical because of that 0 that we're seeing on bottom, right? Those are the cases where there is no slope. So there is a difference between having a 0 slope and having no slope. Guys, just a reminder, you can pause this video at any time if you need to slow things down and make sure you're getting all the notes filled in. Part D, last one, I'm going to do my y minus y over x minus x. So if we did a little cleanup on that, 1 plus 1 is 2. So on this one you can see that I do have a negative slope, right? Which means this graph is going down and to the right, right? So I get a line that looks like this. So a negative slope is one that we would say is falling. And so those are the 4 different kinds of slopes that you can run into when you're classifying these. So go ahead and flip that over. All right. So getting into the last one, the ones that you're seeing right here, these are just some extra practice. For example, in the notes that I just did on the previous page, I mean, we covered all the possible cases. So as long as you have those in your notes, you'll be able to use those for reference. All right, so here's the last thing we're going to look at today for just example 3. So in this case, now we have two different lines. I have line 1 and line 2, and we want to be able to compare those lines. So this is something that I talked about at the start of the video here. If these guys have the same slope, we know that they're parallel. If they have opposite reciprocal slopes, they're perpendicular. And if neither of those cases are happening, then they're just simply two lines that are not parallel or perpendicular. So let's test a couple numbers here and see what we have. So for line 1, if we were to find the slope of this one, again, I'm doing my y minus y, so 3 minus 2 over x minus x, so 1 minus 0. And so we can see that this one has a slope of 1. So now let's take a look at line 2. So I'm going to do negative 1 minus 0 over 2 minus 1. So a little cleanup on that. We're looking at negative 1 over 1, which is negative 1. So if we were to compare, you can see that this is 1 over 1. If I flip this and change the sign, I get this. Right? So I flip the fraction, I change the sign, which means these are opposite reciprocal slopes, which means in this case we now have perpendicular lines. Right? And so we just want to identify that. Guys, when you're doing this in homework, of course I want to see the work, so you got to make sure in all these cases today that you're showing me the work for how you're coming up with these answers. You cannot just say, oh, they're perpendicular or parallel. I want to see the work that is going into making that decision. We're going to test one more. I'd love for you to practice one of these, so you can take a second right now, pause the video. This is the last thing we're gonna do right now. So here we go. Again, I have two different lines. I want to be able to compare them. So if we looked at line 1, again, if I do my y minus y, so I'm doing 3 minus negative 1 over x minus x, which is 1 minus negative 1. So a little cleanup on that. 1 plus 1 is 2. So I'm going to leave this as a fraction for now. Always kind of nice to see your slope as a fraction. Right? It's always good to have a comparison of rise over run. So that'll help. So if I do the same thing with line 2, again, I'm going to do my y value minus my y value over x minus x. So 4 plus 2 is 6. 1 plus 2 is 3. So 2 over 1. And voila, you can see that we do have the same slope, which means these lines are parallel. So we got parallel lines. We'll abbreviate here. Again, always want to show the work that goes into making that decision. So quick side note on these. Remember that perpendicular lines are ones that basically form a T, right? They would form a right angle if you were to compare them to each other, whereas parallel lines are ones that flow the same direction, right? They would never intersect each other. Looking something like that. If you ever run into cases where they're not opposite reciprocal and they're not equal, like these ones were, then we would just say they are neither parallel or perpendicular. Keep in mind when you do say perpendicular, it's not enough just to have reciprocals, and it's not enough just to have a sign change. Both of those things have to happen. So you do need to have a flipped fraction. You also need to have opposite signs. Both of those things have to happen for your lines to be perpendicular. So that's it for lesson 2.2. Make sure you got all the notes filled in. When you do your assignment today, make sure that you are showing all of your work just like I did right here in the video. And I will see you guys next time.